name is Jacob Knoll, and I am here to present the lesson one from the first chemistry unit for high school OpenSciEd. Well, welcome. Let's first start by introducing our phenomenon. And so in this unit, we're going to be kind of making sense of something that we're observing happening in multiple communities. So in this opening of the lesson, what we're going to start by doing is really looking at what's happening and what's occurring at 3 different communities around the world. And so as we make sense of this, it's going to be important for us to kind of make some noticings and some wonderings and see if we can figure out what exactly is happening in these communities, figure out what's similar, and figure out what's different. So in this opening portion, we're going to look at 3 different communities. The first community is a community in Louisiana, and it's indicated by the orange, and we call that community Biloxi Chitima Choctaw community, as well as a community in Senegal and a coastal community in Sierra Leone. So before we do anything, what I need you to do is to take out your science notebook or any sheet of paper that you have on hand, and I need you to create a notice and wondering table. Doesn't need to be super large. You know, it could be 1/3 of the page just to kind of get some, so that way we can kind of record some noticings and wonderings. As you watch 3 videos, in these videos, as you'll see linked on the slide at the bottom left corner, what you're going to do is after you have your noticing and wondering, you'll pause this video and you'll navigate to those 3 videos. And each of those videos are going to have community members describing what they're noticing and disrupting their communities. As you watch, make sure you record noticing. If you want to pause the video, that would be good as well. It may be helpful in some of these instances to open up closed captioning, just to kind of help you kind of see in case there's words that you encounter that you're not quite sure on how to spell or you've never encountered before. So what I'm going to do is ask you to pause this video, navigate to the 3 links that you see in the bottom left-hand corner, and go ahead and watch those videos now. Each of them are about 1 minute or 2, so it shouldn't take you that long. But right now, pause this video and go watch the 3 videos linked on the slide. Welcome back. Hopefully you were able to get some of the noticings and wonderings from the 3 videos that you had. And so what I wanted to do was just, normally if you were in class with your peers, we'd share out some of the things that they noticed and wondered. And so what I have here is a sample list from a classroom of some of the things that they noticed and wondered as they watched the same 3 videos that you did. Some of the things that they noticed were that people are affected by increased sea levels. That was something that across the videos they noticed. These people were in warm climates, which, you know, that's kind of an interesting noticing, right? All 3 of them are down and around the equator. And some people have to move, which is, you know, which was discussed in several of the videos. And in the 3rd video, they actually made the claim that people were the cause of the sea level rise, which is an interesting statement. Some of the wonderings that were had were that, is the sea level rise happening everywhere? You know, these 3 communities are just in the warm climate, but what about elsewhere? What's really causing this sea level rise or this loss of homes that you saw? Why are some people having to move, right? Is this everywhere? Is this just in certain places? And to that point, is this happening everywhere? And how can we help the people? So these were some sample noticings and wonderings that some classmates may have had after watching the same video. If there's any of these that you didn't have, take a moment now to pause the video and add them to your list. But this then leads us to kind of consider, in what ways might the challenges these communities face be shared around the world? Do we have enough information about that? Let's take a moment, consider. And do you think other coastal communities might also be experiencing sea level changes? Why or why not? Pause the video. Take a moment. If you'd like to write it down underneath that notice and wonder table, please go ahead and do so. But just consider these 2 questions for a moment. Okay, so in order for us to understand whether or not other communities are experiencing this sea level rise as well, we got to figure out, how are we going to measure sea level rise? Well, there's 2 main instruments that have been used to measure how high the seas are. The first is a tide gauge, and this has been used since it was first used around 1900. And what this uses is a series of tools and lenses in line of sight to judge how high the sea level is. Even through the high tide and low tide, it allows you to collect some data about how high or how low the sea level is from year to year. Since about 1982, as the space exploration started to increase, we've shifted to using satellites as our main method of determining sea level height. And so what we're going to do is we have some data from both of these tools. And what I'd like you to do is to take a few moments, look at the graph, and answer these 4 questions in your notebook right below your notice and wondering table from the opening 3 community videos. The 4 questions you're going to be answering are: what do you notice about the data in the graph? What do you predict the data will look like in 20 years? Do you think the rate of sea level rise will increase, decrease, or stay the same? And how would this affect the people living around the communities and around the coastal regions? So take a moment, pause the video, and record the answer to those 4 questions in your notes. Great. Welcome back. So we have our answers to those 4 questions about the data set. We see that there's an increase in sea level over the last several decades. And so what we want to do is we made some wonderings about projections and about what this will look like moving forward. But we have a tool. So we mentioned earlier that NASA had used satellites to determine where sea level is, and they've also determined a projection tool. And so what you'll see on the slide is a link. And what I'd like for you to do is to take a moment, navigate to that link. I know it's a longer one, but take a look and see. And you'll see an image similar to what you see on the slide, where there's lots of data points in different communities, some around the equatorial region, some near the polar regions. So just take a few moments, maybe pick a location near where you are, and just see how will that region be impacted by sea level? Is it the same? Is some places higher than others? Are there some places not affected at all? So navigate to the link and add to any noticings and wondering, either to the original table you made, we watched the community videos, or if you'd like, you can create a new table below the 4 questions that you just answered on the tide graph. So go ahead and take a moment to pause the video to explore NASA's sea level projection tool, and make sure you record any thoughts or noticings that you notice as you look at multiple places on the map. Okay, so you've just got finished looking at multiple locations around the world and projections of sea level rise. Hopefully you saw that there's many regions that are affected. Some are affected more than others. But it's kind of hard to tell because there's a range of meters or feet at the sea level. What does that exactly mean? So NASA has also put together a visual, so that way we can kind of figure out what this means that the water is going to rise a meter or 1.2 meters. What does it actually look like? So what we have here are 3 different communities here in the United States where we took an actual picture, and when the projections were calculated, where would the water reach? And so as you look through here, this is what would be both through permanent flooding. So the sea level rises, and that's where the average or consistent level is located. But also in case you have a storm surge from a hurricane or from a storm. So just take a few moments. Just take a few moments and look at that. We have a bakery in Ocean Beach, New York. We have a U.S. Coast Guard station in Texas, as well as a neighborhood where people live every day in Reedsport, Oregon. Maybe add a couple notes in your notebook as well. Okay. So we're going to pause here for a moment, and I'm going to ask that you take a moment to think. Again, if you'd like to write these thoughts down so that way you can bring them to class tomorrow, please be my guest. But what I'd like you to consider is, what did we notice in the data, both in the exploration of the NASA projection tool, but also the sea level? What did we see? And why do you think, if we're thinking all the way back to our 3 community videos, why are some communities responding differently than others? Well, third is, what could be causing sea level rise? So we see that sea level rise is rising in so many different places. But why? What's causing this? And something to also consider is people who are being forced to move. Are they the ones at fault, right, for why they have to? Pause the video, take a few moments, consider the questions, add it to your notes, and then we'll move forward. Okay, well, welcome back. Let's define this problem because we've seen this in multiple communities. There's been lots of terms that we've used to describe people that are displaced by climate change. But it might be really important for us to take a moment and consider how should we be referring or naming these people that are having to move because the seas are rising and they're forced to move. And so let's consider a question. What initial ideas do we have about why we should have a common term to describe people who are displaced by climate change? Take a moment, consider why should we have a single term? What advantage might it have? And what disadvantage might we be trying to avoid? And once we've considered that, let's see if we can use some information to really try to figure out what we could use as a way to name people who are affected by the sea level rise. So what I have is an excerpt from several sources that kind of describe some potential terminology or names that we can use. And so what I'd like for you to do is in a moment, on the screen, you'll see the article. I'd like you to read and consider what terminology is presented in the articles. And once you've seen that information, consider how would you describe people who are having to move because of climate change? Is there a particular term that you think would be more advantageous or more positive or more helpful when referring to people who are impacted by sea level rise? So I'm going to show the article. Make sure that you pause the video. And then once you pause the video, read the article. And if you need to add any notes in your notebook, please do so. So here's the article. And at this time, go ahead and pause the video. I forgot to put an icon in the upper right. Pause the video so that way you have a moment to read. Okay, so now that you've read the article, write a sentence in your notebook. What term do you think makes most sense? What would be the most helpful for naming the people that are impacted by climate change? And that's the end of the first day of lesson 1. So if that's the day that you're absent, go ahead and pause the video here. We'll begin day 2 here in a moment. Welcome back. My name is Jacob Knoll. We're presenting the second day of the first lesson in high school, in the first unit of high school OpenSciEd chemistry. So yesterday or in the previous day, we took a look at the problem that we're presented, and we're building off of it from there. So as was seen in the previous day, when you were looking at and defining the problem, what we want to do is we want to consider some questions. So to get us started on day 2, let's consider these 4 questions. What are other examples that you've encountered where the level of water has changed over time? What do you think causes those change? And do you think people have encountered sea level rise before, or is this a new phenomenon? And the other question, maybe a little bit bigger, is how much of the earth is water? Where is all that water located? So take a moment, pause the video now. If you'd like to record some thoughts in your notebook, please record some thoughts in your notebook. Okay, so now let's continue. So I have some pictures here. Let's go ahead and take a moment and see if we can notice anything that will help us make sense of kind of what we're seeing. So here we have 4 different places. We have Hubbard Glacier in Alaska. We have Mississippi River in Missouri. We have sea ice on the Arctic Ocean, and we have Yellowstone Lake in Wyoming. So what I'd like for you to do is take a moment. Where can we see these types of features on Earth? Where can you see the glacier, or what do you see in the image of the glacier in Hubbard in Alaska? Where else would we see something similar to that? Or if we're considering the Mississippi River, what features do you notice in that image? Where else would we see things similar to that? Take a moment and consider. Okay, so this is the first unit of high school chemistry. So the last time you likely encountered chemistry was in middle school. And so if we consider a moment, um, in chemistry class, we have to remind ourselves, what are the types of things we're trying to learn here? What are we trying to make sense of? What lens are we looking at the world as we try to investigate it? And so we were looking at sea level rise. This is a chemistry class. And in a moment, we're going to start to model what we think is an explanation for why sea levels are rising. But before that, we want to approach these models with what we're hoping to gain out of this course this year. And so what I'd like for you to do is just take a moment and consider two questions. What types of things have you learned about chemistry in prior classes? Because we want to build upon the knowledge that we have, that we've built so far in the 14 to 16 years that we've kind of lived on this earth. And what types of things do you expect to learn more about this class? Because that helps to prepare. So that way we can look at this modeling and making sense of sea level rise under these conditions. All right, so take a moment and consider those two questions. You can pause the video now. Okay, so now that we've considered what we've learned about chemistry in the past, now we're ready to go ahead and start to model. So what we're going to do is we're going to create an initial model. This is what our thinking is right now. And whenever you model something, what that is you're showing what your level of thinking is right now. And the hope is that we can figure out all of the things that we think might be relevant or we think is playing a role, but also identify any areas that we are uncertain about or something we need more information. Because knowing what we do know and knowing what we don't know is really important at the beginning of any phase. And so in this model, when you receive the document, and I'll provide a link so that way you can add it in case you're in the instance that your teacher didn't provide one to you. What I'd like for you to do is to consider two questions. What is causing the sea level to rise all around the world? Because if we go back to our projection tool from NASA, we saw that sea level rise is impacting every continent and nearly every coastline around the Earth. But really, chemistry, as we talked about, we talked about atoms and molecules and chemical reactions. And so we want to think about what is this looking like at the particle level, which is the lens that we look at for chemistry. And we're trying to push towards understanding the world at the particle level. So smaller than cells at that atomic and molecular. So we want to think about what's happening at that level to cause the sea level rise in this big scale. Okay, so those are the two questions that we're looking to explain. Okay, so what you'll see on the slide right now is a link. If you navigate to that link, it'll give you a forced copy of the initial model document. If you don't have a physical copy of that, you can answer all of the questions and tasks on a separate sheet of paper. So that way you can bring it to class tomorrow. And so what I'd recommend right now is to pause the video, navigate to that link, so that way you can complete your initial model, which is to show your thinking about why sea level is rising and what's happening at the particle level to do that. So go ahead and pause the video now to complete your initial model. Okay, welcome back. So at this point of the presentation, what you should have is your initial model from the document that was given to you on the previous slide. You should be considering what this looks like at the large scale and what this should be looking at the particle scale. In class, what would have happened at this point is you would have taken your initial model, shown it to somebody else, and seen somebody else's. Because whenever we start thinking at the start of the unit, we want to take an inventory of what we know. We also want to see what other people know and bring that all together to create a common understanding about where the classes or community's thinking is right. And so we're going to simulate that because I have some examples of another initial model. But before we do that, we want to always compare what is similar between ours and this other students and what's different, because they might have an idea that I don't. They might have a question that I don't. And when we put our knowledge together and our questions together, we have a larger picture of what's going on here. And it allows for more paths for us to move forward. So right now, what I'd like for you to do is in your notebook, create a similarity and difference chart. Little T-chart doesn't need to be massive, just about a third of a page. And what you're going to do in a moment is on the next slide, I'm going to show you somebody else's initial model. And so what you're going to do is you'll pause the video, you'll look at what they have, you'll look at what you have, and you'll identify what are the things that we both have in common. Because now we can build upon that, because that seems to be something that is probably a part of the process if we both have it. But what are also the differences? Because they might have some ideas or thoughts that you either don't agree with or you didn't consider. Okay. So here is the other student's model. Take a moment, pause the video, look at both of them, the particle level and the larger scale, and identify what's similar and what's different between your initial model and this student's initial model. Pause the video now, please. Okay, welcome back. Hopefully at this point in time, what you should have available to you is you should have your initial model, and you should have the comparisons with the student's initial model that you just observed. So let's take a moment. Consider, you don't necessarily need to write this down, but what was similar and what was different? Because in class, what we would have constructed is we would have gotten into a scientist circle, and we would have first taken inventory. What were the things that seemed to be similar? Let's put those on the board first. And let's organize our thinking about why the sea level is rising at the macroscopic and the particle level. And so we would take inventory of what's similar, we would identify what's different, and we would talk as a group to figure out how can we put this in a representation that we can all agree upon and come to consensus to before we move forward with it. All right. And here's an example of a consensus model. So what I'd like for you to do is to take a moment, pause the video, and identify what do you notice is similar between yours, the students that you looked at, and this class consensus model, and what do you notice that's different? I would pause the video now to give yourself an opportunity to really look at and read all the annotations about what you see. Great. Now let's come back. Now, again, I'll pose the same two questions. What was similar and what was different between your initial models and this class consensus model? Let's pause it for a moment for you to write down any thoughts in your note. And that's the end of day 2. So in a moment, we're going to progress to the third and final day of lesson 1 in high school OpenSciEd chemistry. So if you were present, if you'll be attending that class tomorrow, go ahead and pause the video here. Welcome back. In this section of the video, we're going to be discussing the third day of lesson 1 of the first high school OpenSciEd chemistry unit. And so that if you were absent for this third day, this will cover what was discussed in class. If you need a refresher about what was discussed the previous 2 days in class, please go back and watch the earlier portions of the video to help get you caught up. And so what we're going to do to get this third day started is we're going to consider 3 possible questions. And so what we were doing yesterday was we were doing what scientists do, which is that we really want to focus on systems thinking of what is happening in a system, right? And so a lot of times in chemistry and physics, we consider how energy and matter move into, out of, in between, and within systems, because that energy, that matter is what we're focusing on here in chemistry. And so just to define that sciencey word, a system is a collection of objects that we really care about. And a lot of times we identify these objects and then we consider, okay, where do we find them? What's the boundaries? And how are these objects interacting within those boundaries? And so let's think about our consensus model, which you can refer to either the one that your class has, or you can go earlier in the video where I have an example of a class consensus model. How did we track matter? How is it flowing from, to, in? So where's matter flowing? And then also consider where's energy flowing. And if we consider what systems or system do we care about, what do we need to focus on to really know? So we think about what we saw with the globes and with the Earth, right? With where water's found, right? What systems do you think we need to focus on, right? So what I'd like for you to do is take a moment, pause the video. If you'd like to write down your thoughts for those 3 questions, please write them down in your science notebook, or just sit and consider. Pause the video now, please. Okay. So at the outset of any unit that you're going to do this year, after you've kind of collected your thoughts and you've come together with your community to figure out what we as a community think, to help guide our thinking moving forward, we want to generate questions. We always want to end on a question because that helps to move our thinking forward. And so what I'd like for you to do, since you don't have a driving question forward available to you, is in class, what we would have done is everyone in the room would have collected questions, and we would pose those questions on a board that allow us to see what do we need to figure out, where do we need to go from here moving forward. So to go through that thinking process, what I'm going to ask that you do now is in a notebook or on a Post-it note if you have them, but definitely in a notebook so that way you can bring it to class and use the Post-it notes in class, is let's consider 2 questions. And these questions are going to help us explore this phenomenon of sea level rise. And kinds of questions you might want to consider are, if answered, it would help me understand why the sea levels are rising. Or if answered, it would help me understand why so many communities are affected. Or asking questions about, okay, I understand what's looking like at the big macroscopic scale, but what's a particle level question I could ask that would help me better understand how the particles or the molecules and atoms are playing a role in this? Okay, so take a moment, pause the video, and come up with those 2 or 4 questions that you would like to have answered. Okay, so as we come back, one of the things that we would ask for students to consider is which of these questions are best able to answer in the context of a chemistry classroom. You know, some people's questions might turn to the communities and the finances of the communities that are being impacted. How do we pay to help move or support the individuals around the earth that are being impacted by this? Or there might be questions about the policies of different governments that have either been trying to help or not help. Because in the third video, they spoke about developing countries impacting other countries. And so really consider, take a look at your questions that you wrote down and ask yourself, are these able to be best be answered using what we learn in a chemistry classroom? Are there any ones that seem to be more tied to what we're going to be discussing in chemistry? So that way we can gain more knowledge to answer them. So take a moment now, take a look at your questions. After you've done that, now in our units, what we want to do is after we've come up with our initial conceptual consensus model, after we've considered what questions we have that seem most immediate for us to answer, we have to start considering how are we going to answer those questions. And so what I'd like for you to do is in your notebook, right next to those questions, is consider what are types of investigations that we can undergo in this class that you can do when you return to your classroom that would help you answer the questions that you wrote down. And you know, initially, a lot of times you might consider, oh, we could just research it. But take it a step further. How do we research it? What would you look for? What do you need to see in your research? Because we could research via an experiment. We could research via looking at other examples. But what would you be wanting to look at? Like, so to consider, like, if you saw data, what numbers and what things being measured would best help you answer the questions that you're looking at. Okay? So take a moment, pause the video, and come up with a list of investigations or data that you would want to see to help you answer the questions that you generated. Okay. In this section, you know, what would be recommended is having some sort of science notebook. So I'd refer back to what your teacher shared with you in terms of what you will be using in terms of a science notebook. Hopefully you've been writing your ideas down in a notebook on sheets of paper. Make sure that gets transcribed or gets copied or taped or glued into whatever organizational system your teacher has organized. It's always a really good idea to have lots of extra sheets of paper, so that way you never run out and you're always prepared to write down your thinking. And that's it. So thank you so much for watching these 3 sections for day 1, day 2, day 3 of lesson 1 of the first high school OpenSciEd chemistry unit. Have a great day.